Assalamualaikum warahmatullahi wabarakatuh. My name is Amar Aizat bin Nazri, and I will be presenting to you my final year project as part of my Bachelor in Computer System Security in UniKL MIIT. That is the cross-platform encrypted storage device with the help of my supervisor, by Professor Dr. Sharuniza bin Musa. Without further ado, let's begin by introducing what is this cross-platform encrypted storage device. It is a project that presents a hardware encrypted USB storage device implementing two-factor authentication. That is number one, a fingerprint biometric scanning recognition, and a PIN entry of 6 digits. It is built based off the Raspberry Pi 02W, combining with the fingerprint sensor, a two-line LCD for status displays, and a trusted platform module that is to house the private key of my project. And this presents as a plug-and-play USB mass storage device to any host operating system. So it is cross-platform. It works on Windows, it works on macOS, iOS, and Android, and it does not require any software installation on any of the devices. So the problem statements of why I made this project is, number one, is the compatibility of encryption systems. Every this encryption method solution is only compatible to their respective OS. As an example, Microsoft's BitLocker can only work on Microsoft Windows, and Apple only works on the FileVault only works with macOS and iOS devices. And cross-platform encryption needs additional software such as Veracrypt, and it adds complexity and will out some platforms like mobile devices. Also, biometric access control for file encryption is pretty limited. It does not file encrypted storage is not protected by password and PIN, and even open source implementation such as Veracrypt does not have biometric access controls. So the three objectives I have is number one is to study the limitations and security issues of existing cross-platform file encryption solutions through literature review. Number two, to design and develop a cross-platform encrypted storage device with biometric authentication system. And finally is to test the cross-platform encrypted storage device in terms of functionality, reliability, and security aspects. So the proposed solution is the product, as I mentioned earlier, combining of fingerprint scanner, LCD display, keypad, micro SD storage card, and a TPM 2.0 chip. All these devices work together to form a device that is programmed to store files in a micro SD card with encryption that is derived from the fingerprints and the 6-digit PIN entered by the user. And the best part, it works with multiple operating systems. No software is needed to install on any devices. In fact, there's a bonus in there that there's a PlayStation 5 right over there, completely working with the storage device that I've made. Now, how does this product works? I am implementing the CIA Triad, which is one of the basic core principles of cybersecurity. So the first one is confidentiality, which is that the device employs AES XTS 512-bit file encryption that is applied to the file store in the secure partition of the micro SD card, which we will reference it as the vault. In terms of integrity, the TPM2 chip stores the private key of the vault to prevent key access attacks from disassembly of the device. This means that other attackers may not necessarily be easily unlock the device by stealing the private key. And number three is accessibility. The actual file system presented to the host USB device is still shown as regular SPAT device, and it is very compatible across multiple platforms such as Windows, Mac, Linux, Android, and even iOS. So where and who can benefit from this product? So for an individual, a personal user may have a Windows desktop computer, but they have a macOS MacBook laptop, and they may need a storage device that helps secure very sensitive information about their personal files, and it may help for them to use this device so that they can secure their files and use it on any platforms they want. They can even use it on their phones, such as an iOS phone from iPhone, or even an Android phone that's like from Samsung. And then in enterprises, as shown as the photo, an IT company can use this product to deploy sensitive data and licensed software to computers on the field. So these computers on the field, such as the ATM, they run actual computers that runs Windows. They may need software to be installed by the staff, and those software are very sensitive information, so it is much better to store the software installation files on the encrypted storage device that I've built. And how it can be improved. So as of now, the product is a prototype. Because it uses micro SD cards, it might be a bit slower than high performance drives that uses NVMe. So by hoping that with NVMe, this product can achieve better performance as well as using USB 3.0, so that means that the file transfer can be much more improved than it is currently. And miniaturization. So at this time, the product is based off Raspberry Pi 02W. If this product has the demand and has the potential to be an actual commercial device, miniaturization should be considered to reduce the production cost, and manufacturing the device will be much more efficient. So commercialization. So this product, it has the potential to be sold in real commercial settings in those unique cases as I mentioned earlier, and the production can be locally done within the existing semiconductor makers in Malaysia, such as the ones in Bayan Lepas in Penang. And storage size options can be customized according to users' needs. They might not need a lot to store very few files, or they have a lot of files such as software packages for the computers on the field. It depends on the customer's request. And the cost of making the product, as shown at the table below, that it costs around roughly less than 400 ringgit for me. And if this was sold to the general public, the prices are shown there, recommended prices starting from 799 to 1,499 ringgit, as shown on the table just now.
Alright, let's start the demo. So we're going to plug in the device to the Windows PC and let it boot for a while. So now we'll put the fingerprint and enter the PIN, and now the vault has been unlocked. So now I'm going to try and see that the drive is exFAT formatted, and I'm going to copy a file over there. So I copy two files, and then I note down the MD5 checksum for those two files, just to make sure that the files, we want to try on another operating system and see that the files are exact match. So then we boot to the Linux, and we plug in the drive and do the same process, unlock using fingerprint and the PIN, and it's been detected successfully. You can see the two files of the video have been detected. So now we do the same thing, we check the MD5 checksum for both of the video files, and as you can see that the files both are matching. So it shows that the file integrity has been preserved, and we can just lock the vault again, and we're going to show the settings. So this is the admin panel, so we can identify fingers that have been registered, and we find out that there are 3 fingerprints that have been registered, and then we can also do a delete, and we can enroll a finger. So I put another finger and it will update the key, and we will do identification, and we can also change the pin, the global pin for the device.
And that wraps it up for this video presentation. A huge thanks to my supervisor, Professor Dr. Shariniza, for guiding this project, as well as the assessor, Dr. Delina. Honorable mention goes to the 2 FYP committees for Final Year Project 1 and Final Year Project 2, as well as others at Unicare MIT, my friends and my family. Thank you very much. Assalamualaikum.